Hello everybody, we are going to go ahead and start day 2 of Unit 3. Unit 3 is functions, day 2 is domain and range. Okay, so we're going to go ahead and talk about the domain and range. Domain is the set, notice how set is bold and italicized, of all the x values in a function, and range is the set of all the y values in a function. Okay, the way you can remember it is x comes before y, d comes before r. So domain, first letters, second letters, fun stuff like that. Reminder, this is what set builder notation looks like. The x such that x equals something, okay? That's set builder notation, okay? Notation for domain and range is that it must be in braces. All sets must be in braces. It needs to be in order from least to greatest, and you don't have any repeating numbers. So even if domain has, like, when you're looking at all the points, there's x, the x value of 2 appears twice, you only have to write the 2 once. Okay? So, no repeating numbers, least to greatest, and must be in braces. Now, here are the 4 ways you can give a function, and here are what the domain and range look like for that function. So in mapping, the domain is the starting bubble, where the arrows start out of, and the range are what the arrows are pointing to, the ending bubble. Ordered pairs, the domain are the x-coordinates, and range is the y-coordinates. The table, it's the independent variable, that's your x values, and the range would be your dependent variable, so your y values. Graphs are just going to be the x values and the y values. Or sorry, domain is your x values, range is your y values though. Okay, so here's a couple of examples. You have 9, -1, 4, 5, 7, 6, and -5, 5. Well, the domain, you're looking at the x values. So we got a 9, a 4, a 7, and a -5. We put that in order from least to greatest. None of them are repeating, and we put them in braces. So this is what the domain looks like. -5, 4, 7, and 9. Okay, the range is -1, 5, 6, and 5 again. So I put it in order. The 5s are repeating, so I only need to write 5 once. So this is what the range would look like. -1, 5, 6. Okay? Let's look at the second example. Here we have time and distance. Time is our independent variable because it's going to happen no matter what kind of distance we have. Distance is going to really depend on our time. So that's our dependent variable. So this is our independent, so our x values, which means this is our domain, 0, 2, 4, and 6. It's already in order, nothing repeats. We just need braces. And our range is 4, 5, 6, 7. So again, already in order, nothing repeats, so I just need braces. Okay? So here we have our first bubble, so that's our domain. 3, -1, 4, 6, and -7. We need to put it in order from least to greatest. Remember, -7 is our least. Then we have -1, 3, 4, and 6. So we put that there. Range, we have things that will repeat, 4 and -2. But what's really nice about mapping is that they don't repeat in the bubble. So we just need to take what's inside the bubble. The -2 and 4. And -2 would go first because that is our least number, our smallest number, and that's our range. Okay? Here is what set builder notation would look like for the domain of this. So if I had to write in set builder notation, I'm going to write x such that x equals, and these are all the numbers it can equal. Okay? If I was going to do the range, I just have y's where the x's are and put what y equals. Okay? Did I have that for anything else? No. Alright, now here's one. There we go. Domain and range for a graph. Okay? So, you're looking for the edges of the graph. Okay? We'll see what happens. So you want to look at the edge of the graph. So domain is talking about the x values. These are your x values down here. The edge of the graph is at -2 and at 2. So we're using all these x values in between, above us and below us. So we're going from -2 to 2. That's our domain. Everything between -2 and 2. Now we can't write everything in between there because there's a lot of like decimals in between all that stuff. So we are going to write it as an inequality. And this is called a compound inequality, which we'll talk about more when we get to the actual unit on inequalities. Basically what we do is we write it like this in set builder notation. X such that, and then how we write it is we put the smallest number first, so -2, is less than or equal to, and we say it's equal to because it's actually on the -2. We put our variable in the middle, x, and then that's going to be less than or equal to the 2, the biggest number. And we actually can be equal to because we're touching it. Okay? So it's smallest, variable, biggest, and everything's less than or equal to. Okay? Range, same thing. We're going from -2 to 2, and we're using all the y values in between on both sides of it. Okay? So it would look like y such that the smallest number is -2, less than or equal to, because I'm actually touching it, variable, the y, is less than or equal to 2, the biggest number. Okay? Just want to make sure, there we go. Okay, let's try another one. So here we have arrows, okay? Those arrows mean that it extends past the graph, and it's going to keep going in that direction. Nothing's going to stop it, okay? So when we look at the domain, the x values, it's not just going from -10 to 10. It's actually going past it. Nothing's going to stop it. So this one's going all the way to infinity, and this one's going to the -infinity, okay? So here, our domain is x such that the smallest number is -infinity, is less than, we don't say equal to because that's not an actual number. We can't actually count to -infinity. We do our variable, another less than, to positive infinity. Okay? The other way you could say it is that x is all real numbers. So remember how I showed you could just write x and that weird looking e, and then double r? You could write it like that as well. The range is very similar. Even though this is pointing this way, it's still going up at a much slower pace. So this is going to continue to grow up and out. This is going to continue to grow down and out. So this one's going to -infinity on the y's. This one's going to positive infinity on the y's as well. So our range, again, is from -infinity, which is less than your variable y, which is less than positive infinity. You could also say that y is an element of all real numbers. So y, the weird looking e, and the double r. Okay? Both of those are possible as well. Alright, so now you're going to go ahead and try some of these on your own. You're going to find the domain and range of all of these. Okay? A, B, C, D. Okay? Try your best at D. And E. Try your best at E, okay? We will go over D and E not next class because I'm not going to be there. You're going to have a sub, okay? But the following class, we'll still work with domain and range a little bit more, and we'll talk more about these graphs of more than just points, okay? So we'll make sure we go over these when I get back, okay? If you have any questions, like pressing questions that you need answered immediately, send me an email at mescully@fcps.edu. Sorry, I forgot. You can send me an email then, and I'll try to answer it the best I can in an email. Okay? Other than that, I will not see you next class because I'll be out, but I'll see you when I get back. And yeah, have a good week. Bye. Have a good Columbus Day. That's what you should have because you don't have school on Monday. Have a good Columbus Day. Columbus Day, right? Yeah, we're gonna go with that. Okay, now I just need to say goodbye. Goodbye!